Every year, billions of birds embark on epic journeys, leaving their summer homes for warmer lands. These tiny travelers, some lighter than a coin, cross oceans, mountains, and deserts, driven by instinct and survival. The sight of geese in a V formation signals the changing seasons and reminds us of nature's constant motion. But how do they know where to go without maps or GPS? Year after year, they return to the same nesting or wintering grounds, a feat that has puzzled scientists for centuries. Imagine a warbler, small enough to fit in your hand, flying from Canada's forests to South America, over 3,000 miles. It faces storms, predators, and hunger, yet arrives safely, guided by invisible forces. The Arctic tern travels even farther, from the Arctic to the Antarctic and back, a 50,000-mile round trip, the longest migration on Earth. Each species has its own path and challenges, weaving a global web that connects ecosystems and spreads life. These journeys are not just about survival. They shape the world, linking continents and reminding us of our planet's interconnectedness. The story of migration is a testament to endurance, intelligence, and the power of instinct. Every bird's journey is a thread in the fabric of life, connecting distant places and people. As we watch them pass overhead, we witness one of nature's greatest wonders. Their migrations inspire awe and curiosity, urging us to look up and wonder. The mystery of how they navigate is only beginning to be unraveled. These winged travelers are living proof of nature's ingenuity. Their epic flights are a reminder of the beauty and resilience of life on Earth. Birds are nature's master navigators, traveling thousands of miles with astonishing accuracy. They follow ancient flyways, precise routes used for generations. The bar-tailed godwit, for example, flies non-stop from Alaska to New Zealand, over 7,000 miles across open ocean. Birds rely on a suite of senses: an internal clock, sun and star compasses, magnetic sense, sharp eyesight, and even smell. Like a pilot with a cockpit full of instruments, birds switch between these tools as needed. If clouds hide the sun, they use magnetic cues. Over land, they follow rivers and mountains. This redundancy ensures they always have a backup, making their navigation nearly foolproof. Scientists have tracked birds returning to the same tree or bush year after year, even after journeys of thousands of miles. A white stork might summer in Poland and winter in South Africa, always finding its way back. Their brains process a flood of sensory information, creating detailed mental maps. This combination of inherited instinct and learned experience makes birds some of the world's most skilled travelers. Their journeys are feats of precision and adaptability. The secrets of their navigation continue to fascinate and inspire. For daytime migrants, the sun is a celestial compass. Birds use its position, along with an internal clock, to determine direction. Even on cloudy days, they see patterns of polarized light invisible to us, revealing the sun's location. Experiments show that with just a patch of sky, birds can orient themselves using these cues. At night, many birds switch to navigating by the stars. They learn constellations as youngsters, recognizing the night sky's rotation around Polaris, the North Star. In planetarium tests, birds adjust their direction when star patterns are shifted, proving they use a mental star map. Night migration helps them avoid predators and overheating, making the most of cooler, safer hours. This dual system, sun by day, stars by night, gives birds a reliable compass at all times. Their ability to read the sky is both inherited and learned, refined with each journey. These celestial guides are crucial for their survival. The sky is their map, and they are expert readers. The story of avian navigation is written in sunlight and starlight. It's a testament to the remarkable ways birds have adapted to the challenges of migration. Birds possess a mysterious superpower, the ability to sense Earth's magnetic field. This global compass works day or night in any weather, guiding them across oceans and continents. Scientists believe birds sense magnetism in two ways, through their eyes and their beaks. Special proteins in their retinas may let them see magnetic fields as patterns of light. Tiny magnetite particles in their beaks act like microscopic compass needles, providing positional information. The eye-based sense gives direction. The beak-based sense may offer a kind of GPS, telling them where they are on the globe. Together, these senses form a complete navigational toolkit. This dual system is still being studied, but it's clear birds use the fundamental forces of physics to survive. Their magnetic sense is a marvel of evolution. It allows them to cross featureless landscapes with confidence. The secrets of this sixth sense are only beginning to be revealed. Birds don't just rely on compasses. They build mental maps using memory and sharp eyesight. They follow coastlines, rivers, and mountains, using these landmarks as signposts. Experienced birds remember specific features, a river bend, a mountain pass, a familiar field. Their visual memory is so detailed that pigeons can recognize individual faces and even paintings. As they near their destination, birds switch to local maps, recognizing trees, fields, or even the layout of a barn. Man-made structures, highways, cities, can also become part of their mental maps. Birds constantly update these maps, adapting to changes in the landscape. This combination of large-scale navigation and fine-tuned local memory allows for incredible precision. Their brains are dynamic mapping tools, always at work. The ability to remember and adapt is key to their success. Birds are true masters of both compass and map. Birds also use their sense of smell to navigate, a skill once underestimated by scientists. Homing pigeons, for example, rely on scent maps, unique combinations of smells carried by the wind. Blocking their sense of smell disrupts their ability to find home. Seabirds like albatrosses and petrels use smell to locate food and nesting sites across vast oceans. They detect the scent of phytoplankton, signaling productive feeding grounds. Each island or burrow has a unique scent signature, helping birds find their exact nest in crowded colonies. This olfactory navigation is vital for survival, especially in darkness or over featureless terrain. The world of a bird is rich with scents we can't perceive. Smell is a powerful, invisible guide on their journeys. It's another layer in the complex map birds use to find their way home. How does a young bird know where to go on its first migration, often traveling alone? The answer lies in their genes. Migration is hardwired, with direction and timing inherited from their ancestors. Even hand-raised birds, kept from natural cues, become restless and orient in the right direction when migration time arrives. This instinct is remarkable, but learning refines the journey. On their first trip, young birds build mental maps, learning landmarks, star patterns, and magnetic cues. Surviving the round trip makes them better navigators in the future. In some species, social learning is key. Young birds follow parents or elders, learning routes and safe stopovers. This cultural transmission preserves generations of knowledge. The blend of instinct and experience creates a flexible, powerful navigation system. Older birds are often the most successful travelers. Migration is both a genetic legacy and a learned skill. Each journey is a lesson, improving their chances year after year. Birds are born to travel, but they become masters through experience. Today, migrating birds face new threats created by humans. Light pollution from cities confuses night migrants, drawing them off course and causing deadly collisions. Climate change disrupts the timing of migrations, leading to mismatches between arrival and food availability. More frequent storms and unpredictable weather make journeys even riskier. Habitat loss is the most direct threat. Birds need healthy stopover sites to rest and refuel. Destroying wetlands, forests, and grasslands breaks the chain of safe havens they depend on. Scientists use trackers, GPS loggers, and radar to study migration and identify critical habitats. Analyzing feathers reveals where birds have been feeding, helping target conservation efforts. This research is vital for protecting migratory routes. Understanding these challenges is the first step to helping birds survive. Our actions can make a difference for these global travelers. Protecting their flyways is a shared responsibility. The future of migration depends on what we do today. The journey of migrating birds connects continents, cultures, and people. A bird's survival depends on healthy habitats across its entire route. Protecting these travelers is a global responsibility. Simple actions help reduce outdoor lights during migration, make windows bird-safe, and plant native trees. Supporting bird-friendly products like shade-grown coffee preserves winter habitats. Conservation groups and governments are creating networks of protected areas and restoring vital stopovers. International cooperation is essential. Birds don't recognize borders. Treaties and agreements coordinate efforts along entire flyways. Science reveals the secrets of migration, but the wonder remains. By protecting birds, we safeguard the health and beauty of our planet. We are guardians of the flyways, ensuring future generations can marvel at these epic journeys. The wonder of the winged traveler endures, inspiring us all.